Alright, so this is for example 2. So in this one we are given some numbers in a two-way table. I'm just going to go ahead and write in the numbers that I have on the filled in note sheet on my website. So hold on a sec. Alright, so we've given these tables. In this case we're looking at whether or not the guess was correct for the song versus what decade the song came from. So part A just asks what is the probability that a randomly chosen guess was correct. So we're just finding probability of overall it being a correct answer. So P parentheses correct, and so I just look on my table. Overall there were 61 correct answers out of 120 total guesses. So 0.5083. Part B asks what is the probability that a randomly chosen guess was about the 90s song. So P parentheses 90s. So again, just overall, we have 30 guesses about the 90s song out of 120 guesses total, so 0.25. Part C says what proportion of the guesses were for the 1980 song and were guessed correctly. So we want P parentheses 80s and correct. So this is where you have to be careful because your instinct may be to multiply because that's what we did for and on the first day. But remember, that only works if you know the two things are independent events, which we don't know that. We don't know if whether it being the 80s song has some kind of impact on whether or not it was guessed correctly. Maybe different decades have different rates of correctness, which it looks like they do. So I'm not going to multiply. Instead, I'm just going to look in my table and kind of find where those two things intersect. So 80s and then correct, we can see that 15 people were in that intersection. So 15 out of the 120 guesses were about the 80s song and were correct, which equals 0.125. So then we get to the next question, which is our OR question. So OR means which one or what proportion of the guesses were either for the 80s song or were correct or both. So if we kind of think of that as adding, we add for OR, and that's basically what we're doing, but we need to kind of just double check at the end. So we're going to add overall probability of 80 song was 30 out of 120, plus overall probability of correct was 61 out of 120. And that's how we would do it, except that we need to realize that if we leave it here, 30 out of 120 plus 61 out of 120, these 15 people are being counted in both totals. And we don't need that. We don't need them to be counted twice. That's not fair. It doesn't accurately represent what's happening. We can't count them twice. So that third part of our OR formula says we're going to subtract the proportion or the probability of both things being true, both 80s and correct. So there were 15 people who were in that both section, so 15 out of 120 we're going to subtract just to make sure those 15 people don't get counted twice. So we're left with 76 out of 120, 0.6333. So then we have the next part of the problem. So E and F are both what we call conditional probabilities. Right? So that means that there's some condition, there's a given. So in part E, what proportion of the 2000 song guesses? So when we say that, we're saying given that this is what we're dealing with, given that we're only talking about the 2000 songs, we want to know what proportion were incorrect. So the way I write this, the given is kind of this vertical line, and we always put the thing we're given after the line. So I'm going to say given that it's a 2000 song, we want to know what probability or what's the proportion of incorrect or wrong answers. Okay, now I can use a formula for that. My given formula says probability of both, wrong and 2000s, divided by probability of what we're given, which is that it's the 2000 song. And you can do it that way and you'll get the right answer. But when we have a two-way table, I like to just look at the two-way table and figure it out from that. So if I go back up and look at my two-way table, what I'll kind of see is, since I'm talking about only the 2000 songs, that means I only want to look in the row that says 2000. So if you have the paper in front of you, go ahead and look at that right now. So if I only look at that column that has 2000 song guesses, which is the fourth column that says 21, 9, 30. So in that column, we can see that 9 of the answers were incorrect out of 30 answers total. So of the 2000 song means I only care about that fourth column which was the 2000s guesses. So 9 out of 30, which is 0.3. And then part F says what proportion of incorrect guesses. So again, that's a given. That means I only care about incorrect guesses. The way I would write this, that's given always goes after the line. So given that it's a wrong answer, given that it's incorrect, we want to know what proportion were 70s songs. So 70s given, incorrect. And again, I can use that given formula, but I can also just look at the table. So given that it's wrong means I only care about incorrect answers. So I would look at that second row, the middle row in the table, which was all the incorrect answers. And in that row, 22 were about the 70s song out of 59 guesses total. In that row of incorrect guesses, 0.3729. So then part G. Part G is asking, are guessing correctly and guessing the 70s song independent? So that means, does you guessing correctly, is it impacted by whether you were guessing the 70s song? Or maybe do different decades have different rates of correctness? The way we test for independence, we have a test for independence that says, does the probability of one thing, of one event, equal the probability of that event given the other event? Right? And if those two things are equal, then they are independent. But if those two things are not equal, then they're not independent. So for any given problem, what I need to do is I need to assign, first of all, which one's going to be A and which one's going to be B. It doesn't matter which is which. I'm going to call guessing correctly event A and guessing the 70s song event B. So what I'm actually going to find here on this problem is, does the probability of guessing correctly equal the probability of guessing correctly given that you're talking about the 70s song? So if I look at overall, we had 61 out of 120 correct answers. So overall, there were 61 correct answers out of overall 120 answers. Correct given 70s means if I'm only caring about the 70s songs, if I only look at that first column, the very left side column in my table that had all the 70s songs, you'll notice there were 8 correct answers out of 30 total answers. So if I look at this, 61 out of 120, 0.5083. 8 out of 30, 0.2667. And those two things are not equal. So these two values are not equal. So what that means to us is that overall, there was about a 50.8% chance that a guess would be correct. So overall, it was a little over half. But for the 70s song, it was only 27% correct, 26.67% correct. So it seems like the 70s, or what decade we were guessing, had an impact on whether answer was correct or not, because overall we were more like 50% correct, but for the 70s it was like 27% correct. So that tells us that these two events are not independent. So I would write not independent, since probability of correct did not equal probability of correct given 70s. If those two things, if those two fractions or proportions were equal, then they would be independent because one did not have an effect on the other. But since they're not equal, they're not independent. And that is how we test for independence. So that kind of formula I gave you a minute ago is something that you do need to know and remember, that this is how we test anytime we're asked whether two events are independent. This is how we're going to test for that, is by using that little formula, assign the events as A and B, and then figure that out. Part H is just real quick. If we assume the probabilities remain true for future guesses taken, probability that we get 2 correct in a row. So I just kind of threw this in to connect it to what we did on the first lesson. So if we're assuming the probability stays the same of being correct, then we know for the first time for this table, 61 out of 120 were correct. And if we assume that stays true for future guesses, we want a second correct answer. I'm just going to multiply 61 out of 120. Remember, we only multiply it when we know the two things are independent, and since they told us on this one to assume that the future guesses have the same probability, we're assuming they're independent. So if I multiply those, 0.2584 is our proportion.